Alright, so here we are with Unit 10, Lesson number 5, and this is kind of stuff that we've done already. We're back again, yes, again, to Table J, and this is probably the third or fourth time we've looked at Reference Table J, so you should be very familiar with it. Um, so if you take a look at Table J, it's just the activity series. It lists the metals on the left side from the most active metals at the top to the least active at the bottom. Rarely do you use the non-metal side, so we're just going to kind of pay attention to the metal side anyway. So if you look at it, the way that you would fill this in is, and again, you should already know this, for general elements higher on Table J are more reactive than the elements below them, which means this, that if you compare these two elements, lithium is more active than rubidium, rubidium is more active than potassium, etc. And what you're going to need to be able to do is using Table J, we use this in a unit on acids and bases, is be able to determine if a reaction is going to be spontaneous or not. You know, just because you put two chemicals in the same container doesn't necessarily mean that they are going to actually react with each other. And if you have a single replacement reaction, you can use this table to predict that. And here's how you do that. And this kind of sums up the way to figure it out. And what you're going to do is you're going to look at and here's an example down at the bottom. What you're going to do to determine if this reaction is actually going to occur or not is if you're going to look for the element that's by itself. If it's higher on Table J than the first element in the compound, then the reaction will occur, meaning it will be spontaneous. If zinc is below lead, then this reaction will not occur and it's not spontaneous. Okay, so let's take a look and do some examples. There's 4 here. I'll probably do the first couple. So let's take a look. If I look for zinc, zinc is right here. And is zinc above lead? It is. Now, which means that this reaction will occur. So it will be, the first one will be spontaneous. So what you need to be able to do is, this is just a pain in the neck, is then be able to predict what the products are going to be. So the zinc will kick the lead out, and the zinc will end up being Zn and Cl2, and then you'll have the lead by itself. So this will be as we said, this would be spontaneous. Let's look at this one. Here's zinc, and barium's all the way up here. So zinc is actually below barium. So this reaction will not occur. It's non-spontaneous. So you would not complete this reaction because, why? Because it's not going to occur. So there's no reason to put the products in because those products are not going to form. And if you do the next one, here's calcium, and compare that to chromium. Well, calcium is above chromium. It's way above chromium. So this reaction is going to occur. So you're going to combine calcium and fluorine, and then the chromium will be by itself. So this one's spontaneous, spontaneous, non-spontaneous. Let's do the next one. Manganese is here. Is it above nickel? It is. So this will also be spontaneous. So the Mn will join with the sulfur, Mn, and then you'll end up with nickel by itself. And that's basically how you use Table J. And if you remember back, we've used this table, as I said, at least 3 or 4 other times. We used it in Unit 7 for acids and bases, etc. And that's really it for this unit. And we're going to get into the second part of this unit next.